Right now, as you listen to this, time is passing at two different speeds inside your body. Your head is aging faster than your feet. Not by much, not enough to see in a mirror, but enough to measure. Enough that physicists have confirmed it with an atomic clock sitting on a table. This isn't a thought experiment, it isn't a metaphor. It is one of the most tested and verified facts in all of science. And once you understand why it's true, really understand it, the word time will never mean the same thing to you again. We grow up thinking of time as a constant, a background hum, the same for everyone, everywhere. The universe's metronome, ticking evenly while everything else changes. That's the intuition, and it's completely wrong. In 1905, a 26-year-old patent clerk in Switzerland published a paper that quietly dismantled that idea. Albert Einstein proposed that time is not fixed. It bends, it stretches, it moves at different rates depending on two things: how fast you're moving and how strong the gravitational field around you is. The second one is what concerns us here. It's called gravitational time dilation, and the principle is this: the stronger the gravitational pull on an object, the slower time moves for it. Earth's gravity pulls hardest at its surface and weakens as you move away from it. That means something closer to the ground is in a slightly stronger gravitational field than something higher up. Your feet are closer to the ground than your head. So time moves just slightly slower at your feet than at the top of your skull. The difference over a human lifetime amounts to about 90 nanoseconds, 90 billionths of a second. Negligible for daily life, but real, measured, undeniable. For a long time, this was theoretical. Beautiful math, but math. Then in 1971, two physicists named Joseph Hafele and Richard Keating did something almost absurdly simple to test it. They bought plane tickets, and they brought atomic clocks. They flew extremely precise cesium clocks around the world, first eastward, then westward, and compared them to identical clocks left sitting on the ground. When the planes landed, the clocks didn't match. The flying clocks had ticked differently, exactly as Einstein's equations predicted they would. Time had literally passed at a different rate for the airborne clocks than for the ones left on Earth's surface. Not because the clocks were broken, because time itself had moved differently. Here's where it stops being a physics curiosity and starts being something you interact with every day. GPS satellites orbit Earth at roughly 20,000 kilometers above the surface. Up there, gravity is weaker, which means time moves faster for them than it does for us on the ground. Faster by about 38 microseconds per day. That sounds like nothing. But GPS works by measuring time with extraordinary precision. It triangulates your position based on how long radio signals take to travel. An error of 38 microseconds per day translates to a positional error of roughly 11 kilometers. Every single day. So every GPS satellite on Earth is programmed to run its clock slightly slow before launch, deliberately, mathematically, to account for the fact that time will speed up once it reaches orbit. Your maps work because we took Einstein seriously. So we've established that time bends, that it moves at different speeds in different places, that it responds to gravity like a physical thing, like fabric that can be stretched or compressed. But here's the question that should be bothering you right now. If time can move at different rates, if it bends and stretches, what actually is it? Newton thought of time as absolute, universal, a river flowing at the same rate everywhere, for everyone. Einstein replaced that with something far stranger. Space-time, a four-dimensional fabric in which time and space are woven together, and both can be warped by mass and energy. Time isn't a background constant, it's a dimension, one that gravity can squeeze. Let's follow that thread somewhere uncomfortable. A neutron star, the collapsed remnant of a dead sun, has gravity so intense that time on its surface runs measurably slower than time in open space. Not nanoseconds, not microseconds, seconds per day. And at the edge of a black hole, the event horizon, the mathematics say something that is almost impossible to hold in your mind. Time, from the perspective of a distant observer, stops completely. An object falling into a black hole would appear to freeze at the edge, suspended forever, while the universe continued aging around it. From inside the black hole, from the falling object's perspective, nothing unusual is happening. Time feels normal. It's only from the outside that the freeze appears. Two observers, the same event, two completely different experiences of time. Both of them correct. This is not a paradox. It's not a flaw in the model. It is how the universe actually works. And this brings us back to you, standing in a room, head slightly further from Earth's core than your feet. You are not a passive observer of time. You are an object embedded in a gravitational field, and that field is shaping your experience of time at every moment. Every tall person on Earth has aged, imperceptibly, measurably, slightly faster than every short person. Mountaineers age fractionally faster than miners. Astronauts return to Earth having aged slightly less than the people who stayed behind. Time is not happening to you equally. It never was. Here is the thing that stays with me about all of this. We tend to think of the laws of physics as remote, abstract, things that matter at the scale of satellites and black holes and colliding galaxies, not at the scale of a person standing in their kitchen. But gravitational time dilation doesn't care about scale. It is happening to you, inside you, continuously, in ways that are too small to feel, but too real to dismiss. The universe is not a stage that time passes through uniformly while we stand on it. The universe is a place where time itself has texture, where it pools and stretches, where it moves differently depending on where you stand. You are not moving through time. Time is moving through you, and it is doing so unevenly, shaped by the mass of the planet beneath your feet, every second of every day. Einstein didn't just change physics, he changed what it means to exist in time at all. The universe has no shortage of things that will break your mind, and as it continues to expand, so are we. See you next time.